Good morning, student. I am Gagan from Lapur Khalsa College of Engineering, Assistant Professor in Department of Civil Engineering. So last time we are covering the well well foundations. So why the well foundation is providing and what conditions the well foundation is providing, what are the main objective of the well foundations, and we are also discuss the types of the well foundations. So basically the types, there are the three types of the well foundation I'm recall: open Kazan or well, box Kazan, and the pneumatic Kazan. So what is the difference of these three types? The main difference is that during the construction period, so we will discuss already discussed that. So what is important, at what circumstances we provide the well foundations? If the larger load is there, the pile is not sufficient to take that much load, at that condition we provide the well foundations. Second, in the cases of the bridge, we are providing the well foundations. Third, in the case of the river, the water level is there, so we provide a bridge and transfer the loads from the deeper soil. At that case we providing the well foundation. So that's conditions are there, in that conditions we providing the well foundations. So there are the three types: open, Kazan or well. During the construction of the well, and the well is open from the bottom and the top, and during the construction procedure, that type of well fall in the category of the open Kazan well. Next one is box Kazan well. In the box Kazan well, last time we had discussed the open Kazan well. This is example of the open Kazan well. And bottom box Kazan is the bottom of the well is closed and top is open during the construction, that is fall in the category of the box Kazan. And the third one, that is pneumatic, that will be closed from both top and bottom. Okay, that is a fall on the pneumatic. In the last time we had discussed the last class open Kazan. These are the examples of the open Kazan. This is the box Kazan. So box Kazan, in that you see that first of all we take a section plan. Okay, in this section proper decide a plan section, then further we create a RCC wall like a box. Okay, so after the RCC, that the wall is proper close at the bottom and the sand is filled, sand filling is there. We not why in this picture the sand filling is there, because if your well is tilting some portion, it not properly sink, that will be a major problem. Okay, so avoid to the major problem from the well is sinking properly at 90 degree. So this 90 degree, you make this 90 degree, proper sand filling is there. So below the water, first of all examining the site, after the examining the site, fill the water. Okay, fill the water properly, and the fill the in the water the fill the sand. Okay, sorry, fill the sand properly, and after that sink this well, and after fill with the sand, and after that create a pier above this box Kazan. Okay, so this is the box Kazan. So this one is example of the box Kazan. Next and important, that is called as a pneumatic Kazan. So what is a pneumatic Kazan and what conditions we provide? The in this the working chamber is like that, the top and bottom will be properly closed. This is your proper well is there, cutting edge is there, and cutting edge curb is there, and proper reinforcement providing in that. In the working chamber, in this working chamber there is a bucket and compressed air supply, and this is water line, this is worker airlock, air should be locked, and material airlock. So in there air will be locked. So that wise the what are the advantage of this? The pneumatic Kazan will be, air will be locked, air will be not like pass into this Kazan. So the well is properly goes down in the water, and it not will be tilt. Okay, so this is the category of the Panamatic Basin. So today I am going to discuss a case study related to well foundation construction boundary with the bed strata. So student, this case study of the well foundation is this this Andhra Pradesh Pasighat bridge. This Pasighat bridge, below this bridge we make a well foundation in Andhra Pradesh AP. So important features of the bridge. What are the important feature of this live bridge? So why I'm taking this example, because you understand the concept of the well foundation, so that's why I'm taking this example. Importance features of the bridge, that the important factors of the bridge are: the first of all, the length of the bridge, that is 704 meter. Foundation type circular well is adopt because it's economically, I'm also discussed in the previous slides. Outer diameter is 11.7. You can imagine 11.7 meter. Suppose you provide the pile of the 11.7 meter, that means you are it's very uneconomical. Okay, so inner dia is 6. Okay, so inner dia 6, that means you fill the proper sand in between there, 6 meter. Staining thickness is 2.5. Well curb is well curb height is 4.5. Angle of cutting is 33 degree. Grade of choosing for their staining concrete, that is M25. So this is example to make this circular. What is the construction methodology adopting in this forming of well foundation? The simply, the construction is flowing water is carried out by means heavy machinery like dozers, dump trucker, etc. Pneumatic sinking is there, so it will adopt the third. So pneumatic sinking is there, and the conventional sinking method is adopt this construction purposes. So sand was taken from the river and cleaned before transported and used for their sand filling. So what is the construction problem is there? So discuss the problem, what are the phases during to the sink this foundation. The first problem was facing that the sinking of the well becomes very difficult due to the presence of the large size of the boulder strata, because in the river there are the so many types of the boulders are there. Due to the boulder, the well is not properly sink into that. So basically there the basically the problem is arises every case, because the sinking is difficult. So the difficult part is sinking. So basically there was difficult is finally deciding the foundation level or such strata. It's also very complicated case. Decided the foundation level, at which level we decide the foundation, because the level of foundation it decide the how much you will be take load easily and goes down from there, safely distributing load from the deeper soil. Third one is due to heavy rainfall in the area, reduce working period available in region. Due to heavy rainfall there will be the delay of the construction process. And the main problem cause that is Kazan disease. In the case of the sinking process, pneumatic Kazan, under this worker under pressure may suffer due to decompression sickness. So this Kazan disease is due to the rapid change in pressure, because in the pneumatic Kazan there we lock the air chamber and we not pass through the air into that chamber. So due to the why we are do this, because the sinking of the well is properly do so that's why we provide the locking of the air. So but due to that the Kazan diseases occur. The construction of the this Brooklyn Bridge, which was built with the help of Kazan, resulted numerous workers are permanently injured of Kazan and deceased during this construction, including the designer, sons, and chief engineer of the project is also occurs this disease. So it's very complicated, because inhale oxygen O2 enter our bloodstream, lungs, oxygen leaves the blood and enter into their tissues. So that types of the problem will be occur. So finally I'm conclude that construction of the well foundation in the boundary bed strata call decided effort of a part of executely. And one thing is also remember, you require the proper engineering knowledge. After that, you not without the engineering knowledge and all parameter data of the soil and the site must be, each meter detail required review of the foundation must be carried out. Because if you not having proper data for the each meter, I am, they say that each meter, I am say that each centimeter you required the proper review of the foundation must be carried out based on the actual parameter during the sinking. So it's a very complicated foundation. So we are discussing shallow foundation, pile foundation. In all of the above foundation, the most difficult design and construction foundation that is called as a well foundation. So these are the some references we take. Thank you, and we start next topic. The next one is floating chasms or floating foundation. So this is a typical example of a well foundation. This is example of the component part of the floating chasm. What in this that the proper we make a this is a type of a box chasm. We also the box chasm we also called as a floating foundations. Okay, so box chasm is a proper I'm discussing this previous, the proper make reinforcement with concrete cement and filling the sand and the water table proper support providing from the side from the riprap. Okay, and the concrete pile cap is provided at the top. After that we providing the pier. Okay, so the this is the floating foundation. Next topic is shifts and tilts. So basically what is shift and tilt? Basically during the sinking, the well is not properly stayed vertically in the correct position. Sometimes it slide into one side to another side, so desired position. So that position is called as a shifting and tilts because the water is there. So avoid that shifting and tilting. What are the precautions you should be avoid? We are discussing that topic, and what are the IS recommendation we also discuss in that. So first of all, shifts and tilts. So the well should be sunk straight vertical at the correct position. Sometimes the well tilts onto one side or it shifts away from the desired position. Okay, so the following what are the precaution taking from their shift and tilts? First one is the outer surface of the well curve. Well curve means the lowest pass, lowest portion of the well foundation, that is well curve, and the steining should be smooth. Okay, second, the curve diameter should be kept 40 to 80 meter larger than the outer diameter of the sinking. So due to that, this is the recommendation of the IS code. Due to we are using that recommendation, and we are well should be symmetrically placed and properly goes down vertically, and the cutting edge should be uniform, thick and sharp. It's a simple point. The cutting edge should be properly uniform and sharp, and the degrading should be uniform all side in all the pocket. Degrading means we pull the well, we apply force on the outside equally, so that's why our well is properly penetrate into the ground. Next, the IS code 3955/1967 recommended that tilt should not be generally limited to 1 in 60, and the shift should be restricted 1% of the depth sunk. So it's important point, kindly note that. So these are the types of sinking we are discuss one by one. Okay, so so one thing is that shifts avoid the tilts. Basically sometimes we require some machinery, some required some loads and cranes to pull the well and properly sink into the soil. Okay, so it's necessary. Why we do not uh, provide any tilt, okay, in the structure? Because if there some tilt is there, some shift is there, your load is not properly distributed into their soil. So that's why we are do the best effort, or That is, sometimes its effort is also uneconomical, but we require that effort. So what are the next things? So in the next lecture I'm explaining the all exhibition of higher side. What are the methods to prevent the shifts and tilts? Okay, so in the next class I'm discuss the all things.